This video is going to be talking about scientific notation, but we're going to calculate out numbers using scientific notation. And it's very important to understand because in our world there are a lot of things that are very, very large numbers and some very, very small numbers, and we have to work with them. We would love to use a calculator, but the calculator will not go out that many places in your monitor to be able to calculate it. So with scientific notation, we can use a system, an algorithm, that will help us get to an answer in scientific notation. And then if we want to convert back to a standard number, a large number, small number, you have that opportunity. And if you watch the last video that I put onto our Google Classroom, that's that conversion that I'm talking about that you might want to go to. So if I have these really big numbers, I need to convert them first to scientific notation. If I once have my calculation done of working with those scientific notation numbers and I want to go back to a normal or standard look, well, then you have that option to do that with understanding scientific notation conversion. So I have this example here to start with. If I'm going to multiply two big numbers, I have this number over here of 40 million and I'm going to multiply that by 30 billion. My calculator will not hold that many place values. I can't do it. It's going to say error on it. Or it's going to convert it to scientific notation. So it can do it. Some calculators are advanced enough that they'll convert it to scientific notation and solve the problem for you. But we can do this if we have a calculator that doesn't give us those options. So I convert this 40 million to 4 times 10 to the 7th. Remember how? 1, 2, 3, 4, 5, 6, 7 places from the end of this whole number decimal to put it right after the 4th because I want a whole number usually with my scientific notation. So 10 to the 7th, 4 times 10 to the 7th is 40 million. Then I convert this 30 billion to 3 times 10 to the 10th. Again, review that, how we got there. Remember the places, 3, 6, 9, 10 places to get to that decimal right after the 3, and it started here. So that's where that 10 came into play. Now with multiplying scientific notation, it's very simple to do, and dividing works the same way. When we multiply fractions and divide fractions, actually those are the simplest operations rather than adding and subtracting fractions that come about. And with scientific notation it works the same way. These are simpler than adding because we'll show you that we can actually add or subtract scientific notation numbers. But this is very simple because all I do is take the digits 4 and 3 and I multiply them and I end up getting 12. Okay? I just did those digits, those numbers. And if they were decimal numbers, I still just multiply them in the calculator if I need to and multiply those two numbers. In this case it's 12. And then that would be times 10 to what power? Well, this is what's really cool. All I have to do is add the exponents. So I have a 7 and a 10. I just add them together, and that's my power of 10 right there, 17. So 40 million times 30 billion is 12 times 10 to the 17th power. It's a big number. And leaving it at 12 is not what scientific notation says. You should always have one single digit, but I'm not going to be real critical and say that's not an okay answer. But if I did change that and put the decimal here where it technically should be at 1.2, that would increase this to 18. It would move it one more place to make that 18 places to get to these two numbers multiplied out into a very gigantic number. So 1.2 times 10 to the 18th is technically the correct way to see that scientific notation. But as far as we're concerned, 4 times 3 is 12, and we add the exponents values up and we get that 12 times 10 to the 17th is acceptable. Because now if I wanted to convert that back out, I would have 12 with how many zeros behind it? I'd have 17 zeros there. Very big number to calculate out. So that's multiplying. Well, what if I wanted to divide two big numbers? So I have this gigantic number, and to say what that is, it's big. So 4 times 10 to the 20th power, big number, divided by 2 times 10 to the 15th power, another gigantic number. And it looks like, oh man, I can't do that on a calculator. Absolutely not. So if we converted those, 4 times 10 to the 20th, and then 2 times 10 to the 15th, what are we going to do there is just what the operation says. I'm going to divide those digits. 4 divided by 2 gives me 2, and I'm going to go, let's see, I'm going to go back up here. It's going to give us 2. 4 divided by 2, because of the division, is 2. And now what do my exponents do with this power of 10 or base 10 number? I subtract. We added here when we multiplied. Now I subtract. So 20 minus 15 gives me 5 left. So my answer to this great big gigantic number divided by this gigantic big number gives me an answer of 2 times 10 to the 5th, which is 200,000, which isn't a real gigantic number for a calculator, but it could never have gotten there by putting this number and this number in, because it wouldn't have showed up on our screen. So we did get to a number that wasn't really terribly large, but it could never have gotten there. So 2 times 10 to the 5th, our answer here is 200,000 after I divide this guy by this guy. Now there is a way, if you have been taught this, of shortcuts when I have numbers ending in 0, and you would actually get there, but a lot of times these numbers are going to be different than just a nice 4 and a nice 3. You're going to have like a decimal number there being multiplied to the powers of 10. But in these cases, I made it nice and simple. So if I just take this big number, 40 million, and multiply by 3 with all these zeros, all you would have done was add zeros. If you have ever seen that shortcut with multiplying numbers with zeros, you just add zeros, which would ended up with that big number. Same way here. If you've ever divided with numbers with zeros, you cancel out zeros, the same amount of zeros in both numbers. So if you think about that, if this had 15 and this had 20, if we canceled out 15 of these zeros and 15 of these zeros, how many zeros would you ended up with? 5, which would have been 4 divided by 2 is that 2, and that would have been this number of 200,000. So there are some shortcuts if numbers are ending in 0 for multiplying and dividing, which is the same thing as talking about scientific notation, that we're going to add the exponents if I multiply big numbers or small, tiny numbers, but you're working with negative numbers there. And we haven't really done a lot with negative numbers this year yet in 6th grade. So I'm leaving that off, but it would still work the same way with negative numbers, adding them or subtracting them. And in this case, when I divide, this would be a subtraction problem, 20 minus 15, to get to this 5 in that particular number. Now, if we look at, one more thing we'll look at on this video is what if I'm adding or subtracting scientific notation. We're not going to do any of that so much, but just to put this on the video, if you ever had a big number I needed to add or a very, very small number to add or subtract, I can use scientific notation also to get to an answer that the calculator can't do for you. And when we add or subtract fractions, we have to have a what? A common or same denominator, which comes about because you have to figure out what is the common denominator, and it takes a lot more steps sometimes, and some of us struggle with that. But that's the only way a fraction can be added or subtracted, if they have a common denominator, the same denominator, and you have to work to get that with the equivalent fractions. Well, the same way it goes with scientific notation. My powers of 10, or my base 10 numbers, have to be in the same exponent size. So it works the same way as adding or subtracting fractions, common or same denominator. You have to have this common or same exponent value. So how would I do this in this case? If I have a number with 4 times 10 to the 7th, and I have this guy 2 times 10 to the 6th, how do I get these the same? Well, I can move the decimal. So what if I move this decimal one place and put it over here, what did that do to that exponent? It increased it. So now I have 10 to the 7th here, and I have 0.2 or 2/10 times 10 to the 7th. So now all of a sudden I have the same, not very clear there, this, whoops, not 17, 7, excuse me. So now we have exponents the same, 7 and 7. So now I can just work with the digits, and I know my answer down here is 10 to the 7th because they are the same. Nothing's being added or subtracted. You don't add or subtract denominators when you add or subtract a fraction. It stays the same denominator. Same thing. It stays the same exponent. So all I'm working with is the digits. So what is 4 plus 0.2 is 4.2. So my answer then is 4.2 times 10 to the 7th is adding these two numbers that are pretty good size. It might not fit into my calculator. I can do that, and then I can come back and go, okay, now I'm going to move the decimal 7 places, and what number do I have then? Is, well, let's do it. 4, 2, and move it. Looks like I'm going to have 6 zeros because I moved the 2, or moved the decimal on the other side of the 2, and then I'd have 6 more. So this number plus this number that are big actually is 42 million. And after I convert that out, of 4.2 times 10 to the 7th. So that's adding, and subtracting would be the same way. Subtract the decimals, but I have to have, or the digits, but I have to have these guys, the exponents, in the same value. So I'm moving a decimal in one of these numbers to reach that same equivalency of an exponent. So that is something down the road you may work with more, but right now when we're going to do a project pretty soon in our math class, we definitely want this one of, if I multiply scientific notation, I'm actually adding my exponents. If I'm dividing a scientific notation number from another one, I'm subtracting these exponents. So this would be 20 minus 15 is x, or 10 to the 5th power. This would be 7 plus 10, or 10 to the 17th power. So your signs, multiplying or dividing, is what you need to watch for. So again, review this once we get talking about scientific notation calculations, and that might help you.